As 1 radian. What does that mean? It means length of 1 radius. So degrees versus radians, before I show you what 1 radian is in the unit circle. So this means all the way. This is for all the way around the circle, what I'm about to show you. All the way around the circle, degrees equals 360 degrees. Radians equals 2 pi if you go all the way around the circle. So this bit equals 1 radian. 1 radian equals, you know, whatever degrees in there. 1 radian equals 1, right here. 2 pi equals 1 radian, right? So equals 1 full circle. And this is how I instigated 1 full circle. But when we do problems, it'll make more sense about radians. Radians are another way to calculate using pi, what degree measures are. And some people find it easier to use radians than degrees, because it's easier to calculate. Conversion ratio equals 360 divided by pi, 2 pi, right? So 360 degrees is equal to 2 pi. So the conversion ratio, 1 to 1, would look like that. So the formula would be 180 over pi, or pi over 180. So if you want to move radians to degrees, so you have a radian, and you want to move it to degrees, you'd use the first formula because it gets rid of the pi. If you want to bring degrees to radians, you'd use the second formula because it introduces pi. Here, let's do the first one. Convert 210 degrees to radians. So I have 210 degrees. I want to introduce pi. So I'm going to multiply pi over 180, which would give me 210 pi over 180. Are we done? No, because we can simplify 210 divided by 180, and we will get 7 pi over 6. That is our answer. 7 pi over 6. All right, let's do 135 degrees. Do it before me, hopefully. All right, we're gonna use pi and 180, right? So we're gonna get 135 pi over 180, and then when we simplify, we're gonna get 3 pi over 4. So 3/4 of a pi. And what does a pi equal? If 2 pi is 360 degrees, 1 pi is going to equal 180 degrees. So you just got to go 75 per 3/4 of the way through of 180 degrees for 3 pi over 4. And that's why radians is a lot easier to conceptualize. That's my answer. Let's go. So we're going to do 2 pi divided by 3 times 180 over pi, because I want to get rid of pi this time. So pi's disappear, and I get 360 divided by 3, which is easy to reduce. Get 120 degrees. Answer, 120 degrees. Let's do the next one. 5 pi over 6 times 180 over pi. Pi's cancel. I can reduce 6 and 180 as well instead of waiting. This just turns into 30, 6 disappears, and I will get 150 degrees. There we go. All right, let's find the exact value of the function sine 2 pi over 3. So sine 2 pi over 3 is equal to sine of 120 degrees. We already did it right up here, right? So then sine 2 pi over 3 equals square root 3 over 2 from our unit circle. We know that. We know that this is what it equals. And that's how we'd solve it if it were in radians. We just convert it back to degrees because we have all of our unit circles in 45, 45, 90 triangles, 30, and 30, 60, 90 triangles. Because we have a unit circle, we have a radius of 1 in the unit circle. That's why I'll always be that exact value. Can you guys figure this out? Yes, you guys can. I'm sure you guys can. And I'm sure you guys did it, and I'm just showing you guys the answers. So let's do the first one. That one's sine of 240 degrees, right? Which is -3/2. Cosine of 11 pi over 6 is equal to cosine of 330 degrees, which is equal to square root 3/2, right? From our unit circle. Oh, this one's tangent. This one's also equal to tangent of 45 degrees, which is equal to 1. Sine of pi over 2 is equal to sine of 90, which is also equal to 1, right? Answer. Boom, boom, boom. And we're done. Let's do the last page on this resource page. The other, you have 2 more pages, but I'm going to do those on a separate video. So, this is going to hopefully solidify this trigonometric vocab. The ray is called the initial side of the angle. So right here, whatever's on the x-axis, initial side of the angle. The terminal side is the angle that we drew, right, coming out of the center. And the standard position, the position of the angle is called the standard position, like because of this angle that we created along the x-axis. That's our standard position. We use theta to denote that. So 160 degrees, so you start, so this is just telling you where we start when we're measuring angles on the unit circle. So if we're going to go 160 degrees, we start from this side, quadrant 1, and we go counterclockwise. If it says negative 200 degrees, we're going to start at the same area, quadrant 1, positive x, and we're going to go the clockwise direction to get negative 200 degrees to calculate that. And then we're going to draw our right triangle along the x-axis from here and create our new coterminal, to create our new angle. And then we could figure out which one's root 3/2 using our trigonometric identities. And here we go. We're going to talk about, here's the actual definition of coterminal angles. Notice that terminal sides in the 2 examples above are the same, but they represent different angles. Such pairs of angles are said to be coterminal angles. Just because the angle degree is different doesn't mean that they don't land on the same spot. It's a circle. You're not going a distance away. So if I go 720 degrees away, that will be equal to 0 and 360 degrees, I believe, if I did that correctly. I hope I did. If I didn't, yeah, I did do it. So we know that's true. So find two angles in standard position that are coterminal with negative 30 degrees. Well, here we go. Negative 30. Let's draw that. Negative 30 is going to be, we'll start here and we'll go here. And that's about negative 30 degrees. So we know it's at 330 degrees from the positive end. So we already found one coterminal angle. 330 degrees, because we know going positive, that's 330. Well, if I double 330, if I add 360 to 330, not double it, ignore that. If I add 360 to 330, I'll get the other coterminal angle, which is 690. And I can also work backwards. I can subtract 360 from negative 30 degrees, and I'll get negative 390 degrees to get another coterminal angle, right? So now we're gonna go determine which quadrant the terminal side of the angle and standard position will be based on the given information. So sine theta, so our y is gonna be negative, and our cosine theta, x, is gonna be positive. So what's gonna be positive and negative? Quadrant 4, right? So let's do cosine This one's saying cosine is less than 0. So this is going to be negative in the x quadrant. And tangent is going to be greater than 0. So it's going to be positive. So we know that y is also going to have to be negative. So we have two negatives to get a positive, right? Tangent of tangent is going to be positive. Y has to be negative. So we know this is quadrant 3. Right? We remember that because of this. Right? Draw this anytime you are a little confused. Remember, all in quadrant 1, all are positive. Sine is positive in quadrant 2. Tangent is positive in quadrant 3. And only cosine is positive in quadrant 4. Remember, that's going to help you figure that out a lot easier, a lot quicker. Well, this is the end of the first part of unit circles and reference angles. Thank you, and I will be doing the other two resource pages. Well, for me, 5 minutes. For you guys, whenever long you click on my next video. Thank you.